So let's recall what classification means. Classification means we have some blue points and some red points, and we want to find a boundary that separates them. So now we want a little more. We actually want the boundary to be as far away from the points as possible. So what we do is we add these other two boundaries that you can see as equidistant parallel lines to the main line, and we'll try to maximize the distance between these two, or the margin. But this set is very nicely separable. Let's look at one that is slightly more complicated. Let's look at this set over here. So again, a normal classification algorithm would just find a boundary that splits these points. But we want a bit more. We want a boundary with a margin as wide as possible. So let's think. There are two ways to measure this model. One is by how many points it misclassifies, and the other one is by how wide the margin is. So what are the misclassified points? Well, there is this red point in the blue area, and there is this blue point in the red area. But we also want no points in this margin over here. So let's actually punish these points, which means we'll make them part of our classification error. So the yellow circles show you exactly where the classification error is. And now we have the margin error. So let's look at this margin, and basically we want this margin to be as wide as possible. We want to include this in the error, and we'll see how to do this later. But in a nutshell, our new error for this algorithm is going to be a classification error plus a margin error. And minimizing this error is what's going to give us the algorithm for support vector machines.